Hi, 8th grade, and welcome to lesson 1-8, using powers of 10 to estimate quantities. So by the end of the lesson, I want you to be able to confidently say, I can estimate large and small quantities using a power of 10. Keegan and Jeff did some research and found that there are approximately, wow, that's a big number, of grains of sand on Earth. Jeff says it's about 7 times 10 to the 15 grains of sand. Keegan says that it's about 7 times 10 to the 18th grains of sand. How might Jeff have determined his estimate? How might Keegan have determined his estimate? So looking at the differences, let's see. Jeff says it's 7 times 10 to the 15. And Keegan says it's 7 times 10 to the 18. So there's only one difference, and it's in their exponent. So maybe let's try and think about where Jeff got 15 from and where Keegan got 18 from. Okay, so if we count the zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think Jeff counted the zeros. Well, 18 is 3 more than 15, and I bet if we look here, if we went up until the 7, 1, 2, 3, that's 3 more. So Keegan counted all the numbers up to the 7. So all the numbers up to the 7. So whose estimate, Jeff or Keegan's, is more logical? Explain. To me, Keegan's is more logical. Excuse me. Keegan's is more logical because Keegan includes all of the numbers. With Jeff's, 3 of them just disappear. So Keegan, because he includes all of the numbers. Focus on math practices. Do you think the 2 estimates are close in value? Explain your reasoning. So yes or no, do you think they're close? I want to say no. Think about it. If we had 7 versus 7 with 3 zeros, which one would you rather have, $7 or $7,000? $7,000. So no, they are not close in value because there is a $100,000 difference. Okay, let's do example number 1. Estimate very large quantities. Janelle is comparing the estimated populations of Japan and China. The estimated population of Japan is 126,818,019. The estimated population of China is shown. How can Janelle compare the 2 populations more easily? So these numbers, they're big and they have a lot of extra numbers in them. If we're just estimating and comparing, we can round. So that's what they're doing here. They round the population of China to just 1 billion because they looked at this farthest number to the left. The number next to it is a 4, so we keep it a 1 and add zeros for the rest of it. Then they show us, it says count the zeros to determine the power of 10. I don't necessarily want you to get in the habit of counting the zeros because that's going to get us into the same problem as Keegan and Jeff had. I want you to count the place values. So if we look, we start at the end and go in 1, 2, 3, 4, 5, 6, 7, 8, 9 until we reach 1. Now, at this point, yes, it would have worked if you counted the zeros, but it won't always work. So I want you to not be in that habit. Now the population of Japan, the farthest number left is 1. We look to the next number, it's a 2, so we're going to keep it a 1. And again, fill the rest with zeros. Do not count the zeros, count the places. 1, 2, 3, 4, 5, 6, 7, 8. So we have a 1 times 10 to the 9th compared to 1 times 10 to the 8th. Well, obviously China is bigger because it has 1 more 10th. Let's try it. Light travels 299,792,458 meters per second. Sound travels at 332 meters per second. About how much faster is the speed of light than the speed of sound? So, 299,792,458 rounded to the greatest place value is, so we look to the greatest place value, so the farthest left is a 2. I look to the number next to it, it's a 9. So do we round up or do we stay the same? Round up, so I know it's going to be a 3, and we fill in the rest of the numbers with zeros. Oh, I guess I could have put that in the box. Fill the rest of the numbers with zeros. Okay, then it says there are how many zeros in the rounded number. I don't want you to do this, silly Pearson. Let's say there are blank place values behind the 3. So we are going to count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 place values. So the estimated speed of light is 3 times 10 to the 8 meters. So the speed of light is 3 times 10 to the 8th. Okay. 322 rounded to the greatest place value. Again, the farthest left number is a 3. We look next to it, it's a 2. So do we round up or do we stay? We stay. So that's 3. The rest of the numbers become 0. Again, silly Pearson, we don't want to count the zeros. Okay, there are how many place values after the 3? So we count 1, 2. So there are 2 place values. Estimated speed of sound is 3 times 10 to the 2nd. So if we're doing 3 times 10 to the 8 minus 3 times 10 to the 2nd, we are going to get 3 times 10 to the 6 meters per second faster. Country A has a population of 1, I think that's, oh, it's a billion, yeah. 238,682,005. And country B has a population of 1,106,487,394. How could you compare these populations? See, I still have a problem with that. So in order to compare the populations, we do what we just did. We are going to round to the greatest place value. And then we are going to put it into scientific notation. Okay. Example number 2. Matthias used a laser to measure the average thickness of human hair. A sheet of paper about 0.0013 meters thick. How do the thicknesses compare? Okay, so again, and here's the other thickness. They don't put it in the question. You gotta look at the picture. Write the estimated thickness of human hair using a single digit and a power of 10. So again, even though now we're using decimals, you still look to the leftmost number, which is a 1. Look next to it, that's a 7, so we're going to round up to 2. Then we don't worry about any of the numbers after the 2. We just count the place values. This is why I don't want you to count the zeros. You're going to count the place values. 1, 2, 3, 4. And the decimal always goes after the number. Now, something I really need you to notice. if it is a decimal, a small number, your exponent has to be negative. So let's try it again over here with the thickness of the paper. Leftmost number is a 1. We look to the left, or to the right of that, that's a 3, so we're going to stay at a 1. We don't care about any of the numbers after it. We just want to move the decimal to behind the 1. 1, 2, 3. So again, it's a small number. It's a decimal, so it's -3. -4 is less than -3, so human hair is thinner than a sheet of paper. Example 3, how many times as much does the gross domestic product, GDP, of Canada compare to that of the United States? So we have to write the GDP as a single digit times the power of 10. So we look for the leftmost number, which is a 1. Look to the right of that is a 7, so we're going to round up to 2. Every other number fills in with zeros. Again, we're not going to count the zeros. Count the place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is 2 times 10 to the 15th. Next, USA, we're looking again, leftmost number is 1. We look to the right of that, that's a 7. So we're going to round up to 2, fill in the rest of the numbers with zeros, and move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, lost my pen, 16. Okay, so it's 2 times 10 to the 16th. So yeah, USA is bigger than Canada's by a 10, because it's 2 times 10 to the 16th and 2 times 10 to the 15th, which means the first one, USA, was 2 times 10 times 10, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm not going to write out Canada's, but would I write as many 10s? No, I would write 1 less 10, which means that the USA is 10 times greater than Canada. We can use our rules also. 10 to the 16th divided by 10 to the 15th. Remember, you keep the bases. This is the quotient of powers property. Keep the base, subtract the exponent. 16 minus 15 is 1. So the answer is it's 10 times greater. And these exponents were positive because it's a big number, not a small decimal. Try it. There are approximately 1,020,000 cars in the world. The number of the cars in the United States is approximately 239,800,000. Compare the number of cars in the world to that of the United States. Try it on your own. Pause, press play when you're ready. All right, first I'm going to change these into scientific notation. So like the leftmost number is a 1, the next number is a 0, so I'm going to fill in the rest with zeros. So I'm looking at 1 billion. I'm going to count my decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1 times 10 to the 9th. Now I'm looking at this 2. Number next to it is 3, so I'm going to keep it at 2. Fill in the rest of the numbers. And count the decimal places. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 2 times 10 to the 8th. All right, I want to compare them. 1 times 10 to the 9th is greater than 2 times 10 to the 8th because this exponent is bigger. Okay, even though the base numbers aren't bigger, it would still be 10 times more because it's going to have that extra decimal. So the key concept, you can estimate very large or very small numbers by rounding the number to its greatest place value and then writing that number as a single digit times the power of 10. The biggest thing you want to know for very large numbers, the exponent is positive.